Hi everybody, Patrick here from EngineeringShock.com, PaintballProps.com, and EscapeRoomElectronics.com. This is Project 11 for the Arduino Playbot. The Kickstarter is linked below. As well, Project 10 is linked below because this is a continuation of Project 10. And in this video what we're going to do is we're going to use the analog to digital representations of each button on the Resistor keypad, and we're going to decode it using software. Now, fully commented software will be included for each of the project videos to all of the pledges of the Kickstarter campaign. That said, we've got our same connections as our last video. We've got LCD control dip switches 2 through 7 turned on. We've got dip switch 1 turned off. That is the LCD backlight control pin, and we're forcing it on by adding this 2-pin jumper to the EN pins. That forces the backlight of the LCD on permanently. We've got the keypad connected to the KPD 3-pin header right here, with the red wire connecting 5 volts, 5V, to the VCC pin on the back of the keypad. The black wire in the middle connected to AD for analog to digital, which is connected to analog pin 4 on the Atmega 328PU, connected to the out pin on the back of the keypad, and the white wire connected to the rightmost pin, GD for ground, to GND on the keypad. So that said, if you haven't already watched Project 10, again link below, watch it, and this video will make much more sense. So with everything set up, as soon as I power up, the LCD will just be blank. I'll zoom in on the LCD in just a minute so you can get a better idea. The LCD doesn't look great to my camera, but it looks perfect to the human eye. So I'm going to press a button on the resistor-based keypad, which will send specific analog voltage to analog pin 4 on the Atmega 328PU. The software will decode it and say, okay, this value equals button 1 through button 10. So let's press button 8. You pressed number 8. And then the LCD clears again. Let's press number 2. You pressed number 2. Let's press 10. You pressed number 10. So now I'll give you an up-close look at the LCD just so you can get a better look. So I'll press button 9. You press button 9. Now how we're able to do this is within the program, every time the Playbot receives a value, it's constantly scanning analog pin 4, and once it reads a value more than roughly 200 millivolts, it waits for a short period of time, 10 milliseconds, to overcome switch debounce, because every time you press a button on the keypad, there's an element of switch bounce, and that delay simply waits for the switch bounce to leave and then allow for the voltage to settle on the analog input pin. So as soon as you press a button, it waits for a debounce, and then it takes a sample. And that sample is compared against many other numbers. And if it reaches a certain window, if it's between a certain window, then it says, okay, this is the button that's pressed. Return that button, and then display it on the LCD. So I'll just press button 1, you pressed 1, 2, and 3. So it's a resistor-based keypad, so every single button is connected to a different voltage on the rail. We're dividing 5 volts by along 10 resistors, so we're getting different values are connected to each button, which is sent to the input of the analog 4 pin. And so this video is just talking about the software. The software will be fully commented, and so you'll be able to follow through it really easily. Now, the next video is going to be a bit more complicated. What we're going to do is we're going to create a combination lock that employs the relay, and we're also going to employ EEPROM memory. So we're going to program in our own custom code, power it off, power it up again, and after we power it up again, the unit will remember that specific code. Only that code will activate the relay, and the relay can act as a high-powered on-off switch for any DC device or AC device that you'd like. We'll probably use a lamp or perhaps an electromagnetic lock of some kind in that video. I haven't decided yet, but it's much more complicated, but all of the software that's included in the Kickstarter pledges will be fully commented so you can follow along. If you haven't already, check out the links below. There will be a link to a previous tutorial video on how resistor dividers work, as well as Project 10 and the Kickstarter campaign. So thanks everybody, have a great St. Patrick's Day and a great weekend. Take care.